Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. So today we will do with the curved linear charge distribution. Okay. So basically electric field,
like in a ring.
correct. So electric field due to a arc. The idea is, it is obvious that this is a linear distribution, so I'm not specifying it as a linear distribution, but here one thing that we have to mention is that lambda is basically constant. That means we have a uniform distribution, right?
Yes, sir.
Uniform distribution. Now let's see. So basically let us say that there is an arc which subtends an angle 2 alpha at the center. Okay.
Yes, sir.
So we are trying to find the electric field due to this arc at a point at the center. Basically, let the center be O. So what is the electric field at the point O? Okay.
Yes, sir.
Now it is given that the total charge that is present on the arc is capital Q and the radius of arc is capital R. Okay. And it is given that lambda is constant. Okay.
Yes, sir.
Now, how we will solve it is basically at an angle theta. So first, obviously we are in distributed charges, so we have to bring in calculus, right?
Yes, sir.
So again we'll start off with the song, and in the song the first thing is reference. Taking the vertical line as the reference line, because the wires are both symmetric on either sides. At an angle theta, take a small element subtending an angle d theta. Okay. Take a small element subtending an angle d theta. So this angle is basically d theta. Okay.
Sir, when you're telling theta and d theta should be inside of theta.
No, not inside of theta. At an angle theta, shift the radial line by an angle d theta. At theta, shift the radial line by an angle d theta.
Yes,
okay.
Sir.
Let the length of the arc subtended by this angle d theta be dx. Okay.
Yes, sir.
And the charge in that small dx be dq.
Yes, sir.
Right? So the electric field due to the charge dq at the center will be in this direction and it will be some dE. Correct?
Yes, sir.
Now, because of symmetry stuff, see, obviously as my element is varying, the direction of my dA keeps on changing, right? So I cannot directly integrate dA. Correct?
Yes, sir.
because we cannot integrate a vector whose direction is changing.
Yes, sir.
So we will take components of these. We will get two components. But because there is symmetry in my diagram, instead of doing integral of two components, I will do integration of only one component. So how will I do it?
Yes, sir.
Symmetrically on the other side, let us say at an angle theta, again I take another element subtending an angle d theta. Okay?
Yes, sir.
Because of symmetry, again this fellow will have a length on the arc as dx.
dx and dq
Let the charge be dq.
and
Okay.
dE.
And the electric field due to this particular element is d. Okay.
Yes, sir.
So what is happening over here? So this is point O. In this direction I have D. This is my vertical reference line. In this direction I have D. Now if you see, if this angle is theta, that means this angle is theta, right?
Yes, sir.
That means this angle is theta and this angle is also theta. So my D sine theta and D sine theta will cancel each other.
Yes, sir.
Correct?
Yes, sir.
So my resultant vector will be 2D cos theta. Is this clear?
Yes, sir.
So I have to integrate what? This 2D cos theta fellow I have to integrate.
Yes, sir.
Is this visible here?
Hmm.
2D cos theta?
Yes, sir.
Okay. So my net electric field at point O is equal to integral of 2dE cos theta, right?
Yes, sir.
Let me figure out what is my dE. dE, I will write it as k dq by r square, correct?
Yes, sir.
Charge is dq and the distance from the point is r, so k dq by r square.
Yes, sir.
What is my lambda? Lambda is for the total arc. For the total arc, lambda will be total charge divided by total length of this perimeter.
Yes, sir.
What is the length of that perimeter? Angle subtended is 2 alpha.
And 360 by theta and
Simply the total angle, correct. Eventually you will get the same thing. What we can do is that okay, I'll do the calculation for you somewhere over here. For 2 pi angle, the perimeter is 2 pi r, correct?
yes, sir.
So for 2 alpha angle, what is the perimeter? This divided by this.
Alpha into 2 pi r by
2 alpha divided by
2 alpha r.
so that eventually will be 2 alpha r. So I substituted directly 2 alpha r.
Yes, sir.
Or we can also write lambda as the small charge dq upon dx.
Yes, sir.
Fine.
Yes, sir.
But again, what is my dx geometry? Dx is r d theta. So keeping all of this in view, I can write dq is equal to lambda dx, right? Cross multiplication.
Yes, sir.
But dx itself is r d theta, so my dq will be lambda r d theta. Fine.
Sir, how did you get r d theta?
Theta is equal to arc by radius. School stuff. If this is my theta and this is length of arc and this is my radius r, theta is equal to length of arc divided by radius.
Yes, sir.
So length of arc is equal to r into theta.
Yes, sir.
Yeah. So basically that length of arc is equal to radius into small angle d theta. Fine. So let us substitute everything over here. 2 into my d is k dq by r square into cos theta. Fine.
Yes, sir.
And my dq is lambda r d theta. So eventually it will become 2k lambda r d theta into cos theta divided by r square.
Yes, sir.
R will get cancelled. I can write this as, I can bring the constants outside also. 2k lambda by r integral of cos theta.
Cos theta dt.
Now the question is, what is the limit of theta?
0 to alpha.
0 to alpha, because total angle subtended is 2 alpha, but we are taking mirror images of the elements. So I just have to consider one half of it so that the other half is automatically covered. Right?
Yes, sir.
So it becomes 0 to alpha. So what is integral cos theta d theta?
Sin theta.
Sin theta. Upper limit.
Sin alpha.
So eventually I will get this as 2k lambda sin alpha divided by r. Right?
And lambda is.
And lambda is
2 alpha r.
Lambda is q by 2 alpha into r. So I'll have 2k by r into lambda is q by 2 alpha r into sine of alpha. Basically 2 will get cancelled. So I can write this as kq by r square, right?
Yes, sir.
Into sine alpha divided by alpha. So this is easy to remember, but it is important to remember that in this case I have taken the angle subtended by the arc is 2 alpha. So I got sine alpha by alpha. Okay.
Yes, sir.
Xerox. So what we got is that the electric field vector at the center, the electric field vector at the center due to an arc subtending an angle 2 alpha at the center, we got it as k
Q by r square into sin alpha by alpha.
sine alpha divided by alpha. So this you will have to remember. In this we will have obviously special cases. For example, let us say a quarter of a circle. So for a quarter of a circle, what is the angle subtended at the center?
90 degrees.
90 degree. That means in our derivation, my 2 alpha will become 90 degree, right?
Yes, sir.
That means my alpha is pi by 4. That means my net electric field, let us say this point is O. So the resultant electric field, I'll get it as aq by r square By the way, the total charge on this should be given as Q. Okay. KQ by R square into sine alpha divided by alpha. Right.
Yes, sir.
So here I'll get what? I'll get
45 by pi by 4.
sine pi by 4 divided by pi by 4. So
Yes, sir.
what will sine pi by 4 is what?
1 by root 2.
1 by root 2, and 4 by root 2 will become 2 root 2. Eventually you'll get it as 2 root 2 kq by r square, by r square. Okay.
Yes, sir.
Now the second special case is a semicircle. Do you have a rough book?
But now, yes, sir. Yes, sir.
So semicircle, tell me what will we get? Solve it in the rough book. Total charge is again Q. Let's say the point is O. So the electric field.
I mean 1 by pi by 2, 2 by pi. It will be kq, 2 kq by r square.
2 kq by r square. Right. So
Pi in the denominator.
Pi in the denominator. So we will have sine pi by 2 divided by pi by 2. Clear?
Yes, sir.
So as you said, this fellow will become 1, and this fellow will, final answer will be 2kq by pi r square. Direction is obvious, right? In downward direction. Here also in the downward direction. So you can say minus j cap or something like that. Now tell me, for a quarter of a circle, what will we get? For 3/4 of a circle.
That is 2 pi by 3, so
2 pi by 3 is 3/4.
My
2 pi by 3 is 3/4. 3/4 is basically removing of 1/4 out of a full circle.
pi minus pi, no, 2 pi minus pi by 4.
2 pi minus pi by 2.
Pi by 4.
Baba, this is 90 degree. This is 180 degree. How much will we get here?
There 360 minus 90
Is how much?
minus pi by 2.
Is how much?
There 3 pi by 2.
Thank you. So how much is the? I just want the magnitude.
There 2 seconds. Their magnitudes are root 3 by 2 divided by.
You got root 3 by 2.
Yeah, sir.
Root 3. Interesting. So, okay, let us substitute together. Okay. Hello.
Yes, sir.
Shall we?
Yeah, sir.
So you will get E is equal to.
Oh, sir, I took direct 3 pi by 2. I had to take 3 pi by 4.
Yeah.
Zero. No.
I knew I already knew this is going to happen. What is sine 135 degree? Is
Sine
sine
90 plus 45.
sine 90 plus 45 is nothing but cos 45.
Yes, sir.
Yes, 1 by root 2.
1 by root. Yes, sir.
So what will we get the answer as?
Root 2 kq by r square into pi in the denominator.
Substitute it in here rough.
Okay. And over root 2 kq by r square pi.
I'm waiting. I'm waiting. I'm still waiting. Do you want me to do it?
No, sir. 2 root 2 into kq by r square pi.
R square pi.
Yes, sir.
Okay, so here what should I substitute? This should be sine 3 pi by 4, right?
Yes, sir.
Divided by?
3 pi by 4.
Okay.
Oh, I did wrong. 7 forgot 3.
Okay.
2, it should be 2 root 2 kq by 3 r square pi.
Right. So somehow, like I want to solve this in a different way, just for fun.
Yes, sir.
All these cases are where lambda is a constant, right? It's a uniform distribution, correct?
Yes, sir.
Understood? All these cases are where the lambda is basically a constant.
Yes,
Now,
sir.
now you have a 3/4 of a circle that is present. You have a 3/4 of a circle that is present.
Yes.
Full
How
circle,
many times of that quarter is?
full circle is not present, correct?
Yes, sir.
3/4 of a circle is present. Now, for our situation, what is lambda in this? 2 alpha is 3 pi by 2. For our situation, what is lambda? Lambda is total charge divided by 3/4 of 2 pi r, right?
Yes, sir.
Is this clear? Did you understand this? What is lambda? Lambda is total charge q divided by 3/4 of the entire of perimeter, correct?
Yes, sir.
Because 1/4 is missing. Is this clear?
Yes, sir.
After defining this as lambda, now I will do, let this wire has a linear charge density of lambda. Okay?
Yes, sir.
Let this wire has a linear charge density of lambda, where lambda is this.
Yes, sir.
The alternate method that I want to do, that I want to show, is that suppose I have one full circle with entire lambda.
Yes, sir.
What should be the electric field at the center?
0.
Because every charge dq will cancel diametrically opposite charge dq is electric field, correct?
Yes, sir.
If this fellow has an electric field dE in this direction, the diametrically opposite charge element dq will have a electric field dE in the opposite direction. And this dE and that dE will cancel, correct?
Yes, sir.
The electric field due to this small element dq is dE at the center in this direction, and diametrically opposite another charge dq will have an electric field dE in the reverse direction. The electric fields will cancel each other. When we integrate, every dq will get cancelled by the diametrically opposite dq. Therefore, the net electric field due to the circle is equal to 0. Is this clear?
Yes, sir.
The net electric field due to a full circle is 0. Fine?
Yes, sir.
But in my question, I have only 3/4 of a circle. I do not have full circle. So what I am going to do is, first I am going to consider the entire loop having plus lambda. Okay. And in this 1/4 section, I will add minus lambda. Is this clear?
Yes, sir.
The full circle has linear charge density of plus lambda, and only in this 1/4 quarter of a circle I will have a linear charge density also as minus lambda. So in this 1/4, what is happening? Lambda minus lambda will become 0.
Yes, sir.
So I will draw it over here. What I am trying to say is, I have a full circle, and then one second. I have a full circle, and I have added it 1/4 of a circle. But this full circle has a linear charge density of plus lambda. So that means for this full circle, this quarter also has a plus lambda, correct? This part.
Everywhere it is plus lambda.
Everywhere it is plus lambda. That means this part also has plus lambda.
Yes, sir.
And along with this full circle, I will add on this full circle a minus lambda.
Yes, sir.
What will it eventually result as? It will result as the 3/4 of a circle. It will result as a 3/4 of a circle.
Yes, sir.
Why will it result as 3/4 of a circle? Because this 1/4 has plus minus.
Yes, sir.
This 1/4 has plus lambda minus lambda and will become 0.
Yes,
The
sir.
other 3/4 will still have plus lambda.
Yes, sir.
So now I got my previous question.
Yes, sir.
Correct?
Yes, sir.
Electric field due to full circle, I know it is 0. Correct? Electric field due to quarter of a circle, I already know is this.
Yes, sir.
Correct? But I should not use this Q over here. Remember, that's why I want to write this in terms of lambda now. Okay. What is lambda over here for this situation? Total charge divided by 1/4 of 2 pi r.
Yes, sir.
Correct?
Yes, sir.
So basically that will be pi r by 2.
Yes, sir.
So my total charge Q in this question will be pi r by 2 into lambda.
Yes, sir.
Okay. So eventually I will get this fellow as 2 root 2 k by pi r square into, what is my Q? My Q is basically pi r lambda by 2. Okay.
Yes, sir.
So
Yes, sir.
what will this come as? Pi r will get cancelled.
2, 2.
2 will get cancelled. I will have a lambda root 2 divided by r. Here,
Yes, sir.
a lambda into root 2 divided by R.
Yes, sir.
Correct?
Yes, sir.
Why I want you to remember it in terms of lambda also for quarter of a circle is in situations like this, I can use that particular fellow, this particular fellow.
Yes, sir.
By applying minus lambda, what am I saying? Simply the direction of resultant electric field is varying, right?
Yes, sir.
For this quarter of a circle, it was away from the positive charge. For that quarter of a circle, it will be towards the negative charge. But the magnitude will be same.
Yes, sir.
The electric field due to this particular quarter, let's say minus lambda, is how much? I'll get this k lambda root 2 by r.
Yes, sir.
K lambda root 2 by r. But what is lambda for me? Lambda for me is equal to 2 will get cancelled. 2q by 3 pi r. Is this clear?
Yes, sir.
Anyways, the resultant electric field answer should be combination of these two, right?
Yes, sir.
This electric field plus this electric field should be my answer. Is this clear?
Yes, sir.
So my net electric field for 3/4 of a circle, okay, at point O, let's say this point is O, or I will write it as its center. Okay, the net electric field at center due to 3/4 of a circle, I will get it as same as the electric field due to a minus lambda, right?
Yes, sir.
If we are showing the direction in this direction, so that means the direction should be in this direction. How much will I get it as? K lambda root 2 by r, but my lambda is 2q by 3 pi r.
Yes, sir.
So by substituting that, I will get the answer as 2 root 2 kq upon 3 pi r square. Is this clear?
Yes, sir.
Understood?
Yes, sir.
Why? See, directly also you got the same answer actually.
Yes, sir.
2 root 2 kq by 3 pi r square. But why am I showing you the alternate method also? Because if I will remember the electric field due to this quarter of a circle, this fellow, in terms of lambda, I can directly apply that fellow over here.
Yes, sir.
K lambda root 2 by r.
Yes, sir.
I will show the application of usage of this alternate method in the next segment. Okay.
Yes, sir.
Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.